Hey guys, hope everybody's doing well. This is going to be our first online lesson that we're going to be doing. Right before spring break, we had talked about finding antiderivatives and calculating the area underneath the curve using the different techniques. So we did left Riemann sum, right midpoint, and we did the trapezoid rule. So I told you guys when we did that, those were really just approximations, right? So like when we drew them all out, it wasn't the exact area underneath the curve, right? It was pretty close, but it wasn't definite, right? So that's what we're going to work on today, and that's what the topic is here, definite integral. It gives you the exact area underneath the curve. So for example, if I gave you a, if we had a picture, right, and we're going from, say, A to B, right, those are going to be x values, right, and I have my curve like so, all right, this will be f of x. Okay, so what I want to do is I want to figure out the area as I go from A to B, right? And then we did the different techniques, right? And sometimes we did 4 rectangles, sometimes we did 6 rectangles, or so on. So what we're going to do now is we're actually going to figure out this entire area, right? So you can imagine the more rectangles that we did, the better answer that we got. So essentially what we're going to be doing is when you do a definite integral, it gives you the exact area underneath the curve. So definite integral gives exact area under the curve. Okay, so instead of like 4 or 6 rectangles, or what we're going to be doing is doing an infinite number of rectangles as I go from A to B. Okay, so they're going to be very, very small, but as you add up all the areas of those little rectangles, it gives you the exact area underneath the curve. Okay, now obviously if we did an infinite number of rectangles, that would take a very long time to do each individual one, right? So we don't want to do it exactly like that. Okay, so what we're going to do is, this is your setup of what you're going to do for your definite integral. Okay, so this is what a definite integral looks like. Okay, so you have your endpoints, all right? Those are A and B, okay? Those are going to be given to you. Okay, so we're trying to figure out the area as I go from A to B, okay? And then f of x is your function, okay? So what you're going to need to do, right, is you're going to need to find your antiderivative first. So find antiderivative. Okay, that's what this capital F represents, right? Antiderivative is capital F, right? So we're starting with lowercase f, and we're going to capital F to represent the antiderivative. Okay, once you have your antiderivative, then you're going to evaluate. You're going to plug in the top number and then subtract it by plugging in the bottom number. So it's always going to be top minus the bottom. Okay, now when you plug those numbers in to your new equation, that will give you the area. Okay, and that's what I have here. This integral will give you the area under the curve from x equals A to x equals B. All right, so it's a very, very simple concept, okay? And it's just adding on another step that we've been doing up to this point, okay? So up to this point, you guys have been doing, x squared dx, right? This is an indefinite integral, okay, because there's no numbers here on the integral symbol. Okay, we're just finding the antiderivative. And then once you add on numbers, right, so if I did say from like 0 to 3 of x squared dx, right, this now becomes a definite integral, and you're trying to find the exact area as you go from 0 to 3. Okay, so what I'm going to do is just kind of run through these examples. You guys can follow along as you go. You can have your calculator out if you want to, if that'll help you come up with the values. All right, so the first one says it's the definite integral from 1 to 2 of x squared minus 3 dx. Okay, so the first thing that I need to do is I need to figure out the antiderivative of x squared minus 3. Okay, so that's going to be 1/3. Well, let's go back a little bit, I'm sure. So remember, when you're doing antiderivative, you're going to add 1 to your exponent, divide by your new exponent, right? So this is going to be x cubed over 3 minus 3x, right? So then what we're going to do is you don't need your plus c anymore, okay? So if it's a definite integral, we're only doing it between 1 and 2. You don't need plus c, okay? That's another big difference between indefinite and definite integrals. Definite integrals do not need the plus c. Do not need plus c. Okay. So what I'm going to do now is I'm just going to plug in, going to go from 1 to 2. All right, so always do top minus the bottom. All right, so if I do the top, right, I'm going to plug in 2 in anywhere I see an x term. Okay, so I have 2 to the third minus over 3 minus 3 times 2. All right, so that's the top part. Okay, and then you're going to subtract when you plug in the bottom part. So that's going to be 1 cubed over 3 minus 3 times 1. So top minus the bottom. Okay, so once you get here, all you're going to do is just simplify. All right, so 2 to the third is 8 over 3 minus 6. Okay, now what I'm going to do is I'm going to distribute my negative here, just so I can simplify. Okay, so I have minus 1/3. Okay, 3 times 1 is 3, times that negative 1 will make it plus 3. Okay, so now what you're going to do is just put like terms together. Okay, so I have 8/3 minus 1/3, 7/3, and then negative 6 plus 3 is negative 3. And then if you get a common denominator, you get negative 2/3. Okay, so that would be your answer. Okay, now, but the reason that it's negative is probably some of this equation falls underneath the x-axis. Okay, so we haven't really gotten to this part yet, but it's a pretty easy to understand. If you're trying to find the area, actually let's actually do the equation. So we'll do x squared minus 3, right? Looks like this. Part of the equation, right, falls underneath the x-axis, and then the other part is above, right? So this is, anytime you have the area that's underneath the x-axis, that's going to be negative, and then anything that is above is going to be positive. And we'll get to that in a later section, but that's how you're getting a negative answer for this. Okay, so the next one, 3 root x. All right, so again, change it with an exponent. Okay, so again, you're going to add 1 to your exponent and then divide by your new exponent. So this is going to be 3x to the 3/2 over 3/2. Okay, now if you guys simplify that, it's going to be 3 times 2/3, and the 3's are going to cancel. So it's 2x to the 3/2 from 1 to 4. Okay, now another way that you can write this, because it's a root, okay, remember the denominator is your root, and then the numerator is your exponent. Okay, so this becomes 2 square root of x cubed. Okay, and we're going to evaluate that from 1 to 4. Okay, so I'm going to plug in 4 first. So I got 2 square root of 4 cubed minus 2 square root of 1 cubed. All right. 4 cubed comes out to be 64. 1 cubed is 1. So square root of 64 is 8. Times 2 is 16. And then this becomes 2. And then your final answer is 14. Okay, the next one, going from -1 to 3 of 3x squared minus 2x minus 1. Okay, so again, add 1 to your exponent. Divide by the new exponent. Add 1 to your exponent. Divide by new exponent. Minus x. Okay, so if you guys simplify that, that's going to be x cubed minus x squared minus x from -1 to 3. All right, so again, remember top minus bottom. So you're going to plug in top number first. So that's going to be 3 cubed minus 3 squared minus 3 minus -1 cubed, -1 squared minus -1. Okay. So you got 27 minus 9 minus 3. Okay, minus -1 cubed is -1. -1 squared is 1. And then plus 1. All right, so 27 minus 9 is 18. 18 minus 3 is 15. And then you got -1 minus 1, which is -2. -2 plus 1 is -1. Now, if I distribute the negative there, this becomes plus 1. So your answer, 16. Okay. The next one, going from 5 to 10 of 2 over 3x squared. All right, so rewrite as much as you can before you get started. All right, so this will be 2/3 x to the -2, right? Because the variable is in the denominator, right? The exponent becomes negative. Okay, so you're going to do now 2/3 x to the negative first, right? Add 1 to your exponent, divide by your new exponent, and we're going to go from 5 to 10. Okay, so let's rewrite this a little bit. So we're dividing by -1, right? So that makes this negative, and then 2/3 x to the negative first. You can put the x now back in the denominator. So this will be 2 over 3x. Okay, negative exponent. You can put the term in the denominator, and you're going to go from 5 to 10, right? So top minus bottom. So you got -2 over 3 times 10 minus -2 over 3 times 5. So this will be negative 2 over 30, okay, plus 2 over 15. And then if you get yourself your common denominator, this will be now 2 over 30 or 1 over 15. Okay, so rewrite as much as possible. Okay, now again, because of the exponent here, okay, I need to make sure I expand out before I start working. Okay, so we're going to go from negative 1 to 1, and then, again, 2x minus 1 squared. Got to FOIL that out. Okay, so that's going to become 4x squared minus 4x plus 1. Okay. So now what we're going to do, once we've expanded it out, find your antiderivative. Okay, so we got 4x cubed over 3 minus 4x squared over 2 plus 1x, and we're going to go from negative 1 to positive 1. Okay, so now top minus bottom. So we got 4 times 1 cubed over 3 minus, now I have 4x squared over 2. I know that that's going to be just 2x squared. So 2 times 1 squared plus 1. All right, so that's your first part. And then minus, I'm going to plug in now negative 1. So 4 times negative 1 cubed over 3 minus 2 times negative 1 squared plus negative 1. Okay, so this gives me 4/3 minus 2 plus 1. And then over here, this gives me, now negative 1 cubed is negative 1, so this would be negative 4/3, okay, minus 2, minus 1. Okay, so I'm just going to keep simplifying. So 4/3, negative 2 plus 1 is negative 1. Okay, now over here, I have negative 4/3, negative 2 minus 1 is negative 3. Okay, now if I distribute my negative, all right, that's going to give me plus 4/3 plus 3. Okay, so 4/3 and 4/3, that's 8/3 plus 2, right? Negative 1 plus 3 is 2. Okay, so then you got 8/3 plus 6/3, which is 14/3. And that's your answer for that one. Okay, now for letter F. Again, we've done some examples where, if you have the single term in the denominator, you're going to divide that term into both of them, right? You want to simplify first. Okay, so this will be now like x cubed over x minus 2x squared over x. Okay, so x cubed over x becomes x squared, and then 2x squared over x becomes 2x. Okay, so once you simplify, now find your antiderivative. All right, so this becomes x cubed over 3 minus 2x squared over 2, and you're going to evaluate it from 1 to 4. So if I plug in the top number, I'm going to get 64. 4 cubed is 64 over 3. Minus 4 squared is 16. Minus, if I plug in 1, I'm going to get 1/3 minus 1. Okay, so I got 64 over 3 minus 16 minus 1/3 plus 1. So then 63 over 3 minus 15. Now 63 over 3 becomes 21. And then 21 minus 15 becomes 6. So your answer for that one is just going to be 6. Okay, and then these last two, just going to throw in some trig in there. Got the unit circle over here because I'm going to need to use that. Process doesn't change. Still need the antiderivative, and we're still going to be plugging in. So this one's going from 0 to pi, and we're doing 2 plus sine of x. Okay, so my antiderivative becomes 2x, and then remember when we did the rotation, so you start with sine, cosine, negative sine, negative cosine, right? So if we're doing antiderivatives, right, we're going up in the ladder instead of going down, okay? So if I'm starting with sine, I have to go to then negative cosine. And we're going to go from 0 to pi. Okay, so we got 2 pi, right? Plug in anywhere you see an x term, minus cosine of pi, minus, plug in 0, minus cosine of 0, okay? Now, when you guys are doing these, right, remember that cosine goes with the x term on the unit circle, sine goes with the y term, okay? So all the points on the unit circle, right, have x and y coordinates. So cosine goes with x, sine goes with y, okay? So I need, for the first one, I need cosine of pi. So I go over to the circle, cosine of pi, which is here. Okay, I'm looking at the x term, which is negative 1. Okay, so cosine of pi becomes negative 1. So I got 2 pi minus negative 1. And then I got 0 minus cosine of 0. Go over to where 0 is, which is here. Cosine of 0 is the x term. The x term there is 1. So cosine of 0 becomes 1. So now I got 2 pi plus 1, which is 2 pi plus 2. All right, pretty straightforward. Okay, then the last one. Again, going from 0 to pi of 2x plus cosine x. Okay, so this becomes 2x squared over 2 plus, again, we're going up in the ladder instead of going down when we did derivatives. All right, so if I'm starting with cosine, then I have to go up for my antiderivative to get sine. So this would be sine of x. All right, which is really x squared plus sine of x from 0 to pi. Okay. So I'm going to plug in pi. So you got pi squared plus sine of pi minus 0 plus sine of 0. Okay, so again, sine is now going to go with the y term at that point. So I go over to pi. All right, the y term here is 0. Okay, so sine of pi is just going to be 0. And then you got sine of 0. Again, looking at the y term here at 0 is just 0. So sine of 0 becomes 0. So your final answer is just pi squared. All right, so that's how you guys do definite integrals. Not too difficult. Just gotta make sure you're following the steps and always remember to do top minus bottom. So if you guys have any questions, let me know.